Good day to you. This is Anagalactic on Wednesday, March 19th from Chico, California. Today we'll be presenting our third in the documentation series, whereby I am showing you every word that I compose for my paper to be released on spherical geometry. A brand new discovery in science, a geometry of curvature, which is exactly what is needed now. Now, the basic premise of this new geometry is that, of course, it's not new at all. We can see a circle. We can see that it's a plane figure. Why do we use the line? I think we're all fairly acquainted with why science uses exclusively the line in order to form its computational system. It has been proved conclusively that that is accurate, that we'll never leave the linear number system. The reason is a subset of the linear numbers are the representable numbers. These are the computable numbers which allow for binary representation on a computer. Computers only use dyadic fractions. That includes all the whole numbers, but only a subset of the fractions of the whole numbers. I've delved into that to discover that the original number system of the universe is, in fact, fractions. But it has to be much more carefully defined in order for it to be useful, which means computable. Also, it does have to represent something in the universe. Now, the linear number system does not, with one exception. The linear number system furnishes us with a direct measure of linear spatial separation. We call that distance. A synonym for that is length, except length is usually confined to a solid surface. You're measuring a length on a piece of wood. You're not measuring a distance. It's exactly the same measurement, though. And distance is through empty space. That is a distance, but if it's not through empty space, if it's along the surface of a solid like wood, then it is called length. But be assured in your mind, and convince yourself in your mind, there is only one use for the line for physics, and that's the measure of distance. So, we can't use that anymore because Albert Einstein showed us that distance by itself is an illusion. If you're looking for the fundamental dynamic balance in the universe, you cannot do so with linear algebra. It cannot be done because the number system doesn't support the relation that the universe uses. We have a form of geometry based on orthogonality. That works for the computation of distance. When it comes to curvature, you know that we're able to shave off the edges to get what Newton and Leibniz conceived to be a calculus derivative in order to get the slope, the tangent space of the curve for the simplest object, a circle which directly represents a sphere. This is the tangent plane of the sphere. And that has led into bedlam. And so that reduces mathematics to a joke. It's never going to be a joke for men who are devoted to money because linear algebra makes engineering successful because of the calculus. And now for deep space exploration, which requires a higher form of algebra, and for quantum mechanics, ditto, we have not yet discovered the mistake that was made 2,500 years ago by composing a one-component number system. Now, if all of that sounds like gobbledygook to you, it's because you haven't listened to any of my prior videos. So that is the jump-off place for what we wish to go to next, which is basically this. I've covered this aspect of the outline in the first video in this series. This would be the third of those videos. In the second video, I covered this. And then in the third video, which is now, we want to summarize what we learned. This is all three bulleted items from above, condensed. We have line geometry. I think you're already familiar enough with line geometry that you probably believe you don't need my instruction on line geometry because you're perfectly well acquainted with it. Go back and listen to the first video in this series, to disabuse yourself of that self-centered, ignorant notion. You must know the actual line geometry. Only I teach it. From there, we can go on to the circle, where I introduced you to the key core concept, intrinsic geometry. And then from there, we went on to the parameterization of the circular plane, replacing the squared plane. All of that may sound threatening. It certainly will to real scientists, not just to you. And this will be attacked mightily. I don't think it will be, though. It will never be noticed. Now, today, we're covering the fourth in this four-part outline, where I've tried to put together, in some order, a dissection of where this geometry leads us in terms of physics. This is a miraculous geometry. It is a breakthrough geometry that changes the course of science from its currently suicidal course back onto the track that we expect from science. Only this geometry will accomplish that because I found the solution to the quantum paradox. So I'm just going to summarize these bulleted items, which for this page will appear in my third paper. I've made so many major discoveries in the past 3 years, they will not fit into one paper. This will constitute the third paper. This right here will be the first paper. What goes into the second paper, I don't want to confuse you with right now. I believe it would be confusing. So I will produce 3 papers. I'm an excellent organizer. I'm a master at the organization of logical information. A table of contents should be that, but it isn't always. Now for this part 4, I'm calling it spheric dynamic space. This will not be in the first paper. The first paper will be devoted entirely to this, the parameterization of the circular plane. The overall title will be Hyperspheric Intrinsic Geometry, but not initially, because it would drive people away instead of toward what I want to say. So now we complete the outline series, so that you'll show how I'll be able to show you how I expand this into an organized document, which will be translated into HTML, that is text, and LaTeX, which is the de facto standard for scientific papers. I am very good at LaTeX. So there will be 2 formats, and there will be 2 public sites. At one of them, at Google Docs, you'll be able to comment. Leave your comment and your name if you wish, and I'll be able to respond expectedly within a day, if not hours or even minutes. And this will always be also be released at github.io, where I own a free slot for free web paging. An amazing service. So let's begin. Spheric dynamic space. Why do I say dynamic? It is because of the nature of physics. We are now attuning geometry to physics. We cannot attune physics to geometry. It will not comply with our linear algebra. The universe does not recognize 0 as a reference frame. So Einstein's field equation is obviously wrong because it uses the wrong reference frame. Now, Einstein talked quite a bit about reference frame. It baffles the fuck out of any student who first encounters it. And any student, if you're still baffled the fuck about relativity, it's because Einstein was wrong. Okay? So don't worry if you're confused. Now, you still have to pass your courses. I recommend getting out of the college. I recommend dropping out of the university. You may not be able to do that conveniently. I would expect not. But plan it. Some months ahead, plan to get out. Drop out. Drop out, don't get a degree. You'll be brainwashed. You've already been brainwashed. But it's not too late to get out. Now, you may not be able to. In which case, you're in deep trouble, and I probably can't help you. Good luck with your studies. All right. The first thing I will be discussing, although not immediately at this moment, is quantum relativity. This is the hottest topic in town. Nobody uses that term because nobody can see what the problem is. I see directly what the problem is and have solved it with spheric geometry, which has its own number system. So these two symbols, you may not be acquainted with them because your teaching system is flawed. But this is not a V, that is nu. And what it stands for is wavelength. This F you probably recognize its frequency. The two dots represents the relationship between wavelength and frequency. Only I know what that relationship is. In the second part, we have Boshkovicic. That's the right pronunciation, believe it or not. Boshkovicic. It's hard to say. Boshkovicic, infinitesimal space. Boshkovicic, infinitesimal space. It is very bad spacing here. Let me see if I can do something about that. We just outdent that there. That's much better. All right, let's outdent that too. So that may not be consistent, but, well, it still works. So now it's all on one line. So once we're done with quantum relativity and Boshkovicic infinitesimal space, where I will show you the rationalization of infinity for the second time in a second way, then we'll get into hyperspheric gravity electromagnetic space. Gravity and electromagnetism are intimately related. Yes, I have the Einstein field solution for the unified field. I've got it. No one else does. And these are the two aspects of it. In terms of electromagnetism, there is radiative electroforce. You may recognize that as centrifugal force. And then we have what is often called gravity. That is a form of magnetism. I'll be explaining that fully. It contracts space rather than radiates out through space. And those are conjugal orthogonal in spheric space. The rationalizations is a whole series. I've rationalized infinity. There are exactly and only two infinities, and they are related. That must be rationalized. I'm the first man to have done so. There is also imaginarity. Space is comprised of spatial space, which we see and erroneously call 3D, but there is an orthogonality in space that is purely imaginary. That is the imaginarity that is driving physicists out of their fucking minds. And part of their problem is they never rationalized infinity. They're saddled with a zero, which doesn't even exist. And then we go on to the universal reference construct. Albert Einstein defined the special reference frame as zero. Then he went on to define a more general reference frame that's still zero. But he never got the universal reference frame, which is what he was seeking, but he was too stupid to find the way out of his bind. So I finished Einstein's work. I got the universal reference frame, surpassing Einstein, but not burying him. He gave us space travel for local space. Then I deal with a derivative of time. And that's not time having a derivative. That's time being a derivative. Time is a derivative quantity. What is it derivative of? Nobody knows except I know. And then we're going to talk about integral proportional space. What does that mean? Well, that would be the universe. The integral of space? But it's not the integral of space. You'll never get it. You'll keep the infinity. But if you get the integral of proportional space, then you get the actual definition of the universe, and from there you can move to dual space. Normally we now consider that to be time and space woven together. That is an illusion. It is an error. So there's no such thing as the construction of dual space, with the word time in it. Time is a derivative quantity. But in dual space, you deal with integral proportion. And then the duality comes out. It's not the duality that exists between space and space-time or time-space. It's space and energy. It's space and energy, which are integral terms. Now, the problem with space is that it's Euclidean. Well, for 2,500 years, your entire scientific community has been in kindergarten. It's time to go to college. You'll need the quantum of space. That's the solution to the quantum paradox. I got it. And here is the other aspect of the quantum paradox: the transit of the photon through free space. This includes emission, transmission, and absorption, which is called the collapse of the wave function. I'll show you why your physicists misnamed everything, and they'll never get the answer. I got the answer. And then we'll talk about superpositional coordination, the key to space-time. And then we'll talk about hyperspheric rotation. That must sound like, oh, well, I am too dumb to ever understand. Stop telling yourself that. I'm a teacher. I can teach you what hyperspheric rotation is. The chiral in aspect is called gravity, and the chiral out aspect is called electromagnetic radiation. What's the relationship between those two? It is called the Noether symmetry. This is Anagalactic, bringing you the secrets of the universe, and that concludes our 3-part series. Introducing the outline to my 3-paper series. Following this, we're going to construct my first paper together so that it is documented online, every single step I took to make this paper, so you can see how I think. You're going to need to do that, or you'll never be able to think. This is Anagalactic. Stay tuned. Always remember, keep looking up at night. And if you keep doing that,